All right. Good morning, everyone, and welcome to the January California Nevada Drought Early Warning System Drought and Climate Outlook webinar. Thank you for those that have joined us previously and those of you who may be joining us for the first time. My name is Amanda Sheffield. I am a regional drought information coordinator for NIDIS in California, Nevada, affiliated with the Cooperative Institute for Research in Environmental Sciences at CU Boulder. This webinar is co-hosted with the California Nevada Adaptation Program, a NOAA CAP team. We provide these webinar series on a bi-monthly basis, and they're designed to provide the region with timely information on current drought status and associated impacts, as well as a preview of developing climatic events. Before we get started, please note that this webinar is being recorded, and the recording and a brief summary will be available on drought.gov and our YouTube channel later this week. And I believe that's in the chat already, and if it's not, I'll link over to that YouTube channel in case you want to find it, but we should get it out either today or tomorrow to your emails. We've got a great set of speakers this week. Obviously, the drought conditions are heightened right now in both of the states right now, and so we're going to be covering a lot of that today through the update and outlook. And we've got our two great state climatologists here to give their perspectives on the current conditions. Before we get started on all our great speakers, real quick, I did want to give a little bit of background on NIDIS for those who may not be as familiar. Our mission is to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. We work towards this by building a national drought early warning system and through several different regional drought early warning systems, one of them being California and Nevada, where we work with new and existing networks of federal, tribal, state, local, and academic partners to make the climate and drought science information accessible and useful for decision makers. As I mentioned, these drought early warning systems, we do multiple different types of activities from research, prediction and forecasting, planning, preparedness activities, observation monitoring activities, and communication outreach just like this. Quickly, I wanted to mention that we also are providing the most updated information today in the webinar, but we did release a drought status update if you do want to prefer to read it or look for a little more in the detailed information. We plan to do, while the next webinar isn't until March, we do plan to do more of these written drought status updates in February and mid-March, as well as with the webinar. And we do this in tandem with the states and other partners, which are also coordinating messaging about the ongoing situation. And we're just letting you guys know we have a couple different outlets for that information if you're curious as you head along. One other quick thing I wanted to mention, obviously there's been drought developing in the southern, especially the southern parts of the California, Nevada. We actually happen to be working on a pilot in the Southern California region since October, developing how can we deliver some of this different information to some key sectors. There's sector-specific scenarios, for example. We selected ag, public health, water utilities. I quickly mention it. If you are in one of those sectors or are interested in being involved, we're doing these on a monthly basis still through the rest of the season. And so basically we work with these partners over a 2-week cycle to hear their questions and concerns, what information they would like to see. We draft specific information at the global, regional, and sector-specific scale, and we provide that via a webinar and then a document that summarizes all the information. It's very much in pilot mode, but if you're in those sectors and you're interested in participating, please let us know. The QR code takes you to the website, or you can email me. These were just some example maps from the last one where we dig in from all the way to the global scale to what's been happening regionally and things like that. It's the difference between that information and what you receive in a webinar like this is the sector specific information and tailoring of that information to those folks. And we're very much in pilot, so it's definitely an experiment we're working on. With that, I did want to make a plug for if you are experiencing drought impacts, there's a couple of different ways you can report those impacts. One of those ways is a condition monitoring observation report. The website's there on the lower right, but if you are experiencing drought impacts in all different kinds of way. It's not just, oh, is there water here or there? You can have air quality issues, crop issues, all different kinds of things. If you are, we welcome reports going there. And if you need more information on that, check out the website or feel free to contact me, because we do like to hear what's happening on the ground to help confirm what we're feeling in the physical conditions. with that, I'm going to go ahead and pass it over to our first speaker, who's Dan McAvoy. He is a climatologist with the Western Regional Climate Center, and he's going to give our drought and climate update. And Dan, I will make you presenter right now.
All right. Thank you, Amanda. If you can just give me a thumbs up, or if you can see my screen
You are
right
good to
now.
go.
All right. All right. Well, thank you again, Amanda, for the introduction and the overview of this webinar series. I'm just going to go ahead and jump right in because there's a lot to cover today. So I want to give an overview of the ongoing, the most recent conditions related to drought, water supply, snowpack, temperature, and then we'll hear more about the outlook in the next presentation. And I want to start off with the water year perspective in terms of the precipitation totals, and then in a few slides I'll get into kind of the progression of that. And so this map that I'm showing right here, this is from a tool called Climate Engine, and it is using the GridMet gridded data set. And this is showing the water year percent of average for the total precipitation. And so that's from October 1st. And this maps through January 21st, so a few days old, but not a whole lot has changed here. And the browns are drier than average, and then the greens are above average. And so a couple things stand out here. There's a pretty sharp gradient from wet to dry across the region, especially the northwest corner of the region, Nevada and California, that has seen mostly above average precipitation for the water year to date. And as you go south, you see a very sharp gradient with very low percent of average precipitation. And Southern California and Southern Nevada especially, this area shaded in this darkest brown has seen less than 5% of average water year precipitation through the 21st. In some places, Las Vegas, for example, has seen no measurable rain in 197 days, which is their second longest streak. I'll get a bit more into the LA context a little bit later. And so if we have the same map now, except this is the water year temperature anomaly, so the departure from average temperatures through the 21st of January, mostly red on this screen, indicating mostly above average water year temperatures. It has been, for the most part, a warm start to the water year. There are some very small, much smaller areas of blue. But for some context of the historical perspective, for example, San Jose is seeing their warmest water year to date to start on record. San Francisco, the 8th warmest, Reno, 7th warmest, Las Vegas, the 4th warmest. But there has been some below average temperatures, including Southern California, immediately along the coast, which is likely due to the persistence of fog and marine layer there. But overall, a warm start to the water year for the region. This has also led to some higher snow levels that we've seen during particularly during the December storms. And so we had some higher elevation rain in the Sierra Nevada in some of those December storms. So now on to some more recent conditions. If we just look at January now, it has been extremely dry for the entire area. So this is again, the percent of average precipitation on the left, but just January 1st through the 21st. Much larger area of less than 5% of average, and much of the region was less than 25% of average precipitation for January. And the culprit there is on the right here, showing the upper atmospheric circulation pattern at 500 millibars, essentially the middle of the atmosphere. This is showing the anomaly in high and low pressure systems. And so we're seeing the dreaded high pressure anomaly in the Northeast Pacific that is essentially blocking and deflecting storms away from the region. And this particular pattern makes it very difficult to get storms into California and Nevada, especially the southern half of the region. So extremely dry January, and a lot of that wetness we saw in the northern part of the region, we did not see that in January. That was mostly November and December. Now we'll go through some of the progression of how the year is shaped up in terms of precipitation. These are traces from the Northern Sierra region. The blue line on the left here, the dark blue, is this year. And then we have last year and 2 years ago also shown there. And this is the water year accumulation to date. And so we did see some pretty big November storms, and then again an active December for the northern part of the area that got the region well above normal. Then we saw that really dry stretch in January, and things are coming back closer to average, so 105% of average for the northern part of the region. And again, these are through January 24th. So the same plot now, but for the southern region, the Tulare Basin, which is now at 51% of average. So a much different story as you go farther south in the region. There was a big storm around Thanksgiving, and since then almost nothing, and certainly not any big storms to speak of. One thing to note is that this is currently similar to where this region was this time last year, and there was some ground gained over the remainder of the water year, but it's going to take bigger and bigger storms as we kind of try to make up those deficits over the past couple of months. So much further below average in the southern part of the region. A similar type of map using the SNOTEL data now for Nevada for the the Humboldt Basin, which covers much of north central Nevada. This area is right around average for this time of year, the black line this year. And this area is coming off 2 wet years in a row. Last year in orange shown there, and then even wetter in 2023. Right around average, and so not as much of a drought concern, but in this part of the region, but they have had that long dry stretch over the last few weeks as well. So now let's talk a little bit about the snowpack. Some of the snowpack patterns definitely follow the precipitation patterns I was just talking about. And this is showing a map of the SNOTEL stations as well as the California DWR snow pillows here. And this is showing the percent of normal snow water equivalent, or the amount of water in the snowpack. And this was at the end of the day on January 23rd. Again, not a whole lot has changed since then. But what we see is in the northern tier of the region, there's quite a few blues and greens indicating above normal snowpack for that part of the region. But as you get into the Sierra Nevada, especially the southern part, we're seeing a lot of yellows and reds, a number of stations less than 50% of normal for this time of year. And also I want to mention the Spring Mountains in just outside of Las Vegas have almost no snow in the area right now, again, due to that long dry stretch. So snow drought is definitely developing in the Sierra Nevada, particularly the central and southern part of the region, but things are still in pretty good shape in the north, despite that long dry spell due to the very active start to the season in November and December. And again, if we look at some of the progression of these, the snowpack through the season, these are 3 time series plots from the Snow Tracks page, the California DWR site. And so on the top left, we have, this is the snow water equivalent as it's accumulated throughout the season. The light bluish shading is the average or the normal conditions. The gray is last year, and then the black line is this year. So on the top left, we have the northern region. On the bottom left, the central, and then on the top right, the southern region. And so we can see in all of those regions the impact of that long dry spell with not much of any snow accumulation over the last few weeks. Again, the north is right around normal. Central region, 64% of normal, and really far below normal in that southern part of the region at 53% of normal, with no large snowfalls since around Thanksgiving. So looking for a turnaround there. Similar plots now, but again for Nevada, for the SNOTEL, from the SNOTEL network. The top left is that Humboldt Basin in north central Nevada, and then the bottom right is the eastern Sierra Nevada. And again, the Humboldt is in pretty good shape, right around 100% of normal for this time of year. And again, coming off of those 2 above normal years, so looking pretty good in that region as of right now. The eastern Sierra Nevada, similar to what I showed in the rest of California, is rapidly falling below average with very little accumulation in the last few weeks. There was this storm over the weekend that did bring some snow to the far eastern Sierra, Carson Range, but the water content was not what we needed to really boost out of that snow drought that is developing, as this region is currently at 64% of normal. And I also wanted to point out, if we look at the eastern Sierra here, especially, you can see this orange line, which is last year. And we're actually still above where we were last year for this time of year. And just to note that if things do pick up, there is still time to recover out of this developing snow drought, snow deficit, but it's going to take more persistent shift into stormy pattern and larger storms as we move forward, since we really missed that January precipitation and snow. So looking at the water supply right now, on the left here, we have the reservoirs in California, the graphs that show the current percent of average and the total capacity percent of average. And then on the bottom right is a table of the Nevada reservoirs showing similar information. And the main message here is that the reservoirs, for the most part, are still in pretty good shape, close to average for this time of year for both states, or above average. And so we had that really big 2023 winter 2 years ago, and pretty close to normal for much of the area for last year. And so that's still providing this buffer in the water supply, with the reservoir still being in pretty good shape. One of the exceptions being the Colorado River Basin reservoirs, Lake Powell and Lake Mead, are still at critically low levels. Nothing substantial has changed really in several years, as that's more on a decadal scale drought right now. And so that area is still in need of a major influx of moisture to the region over a multi-year time period. So if we sort of put that all together and look at what the U.S. Drought Monitor is showing right now, on the left, this was the latest map that was released last week, last Thursday, for our region. And then on the right, it's showing the change in those Drought Monitor classifications over the past 3 months, basically since around late October. And so we see there is still no drought or no shading at all in the northwest part of, or Northern California and the northwest part of Nevada, which is good to see. But then there is certainly drought developing over the rest of the region, and the severity is quite a bit worse as you go further south. We see in southern Nevada and southern California areas of this D2, which is severe drought, and the red is D3, extreme drought. And most of this has developed since the start of this water year due to the dryness and warmth that I was just discussing earlier. However, in far southern Nevada, where you have drought impacts related to the Colorado River Basin again, and those water supply deficits in Lake Powell and Lake Mead, that has been persistent for years now. But for most of the region, this drought has been developing over the last 3 to 4 months, with a very dry start and warm start to the water year. So last thing I want to touch on was some context of the weather and the climate factors around the Los Angeles fires. That was an incredibly tragic event, and my thoughts are still with the community and all those that have been affected by it. So this table here is from CAL FIRE, basically showing the most destructive fires in the state's history. And the Eaton and Palisades are now the second and third most destructive. So I don't want to get into all the details around the fire. What I do want to talk about are kind of the obvious climate and weather factors that were related to this event. Of course, that long stretch with no wetting rains in Southern California. And there was also an extreme Santa Ana wind event, and the combination of things led to really dry fuels and vegetation in the area. So if we look at the accumulated precipitation for the water year, this is from the downtown Los Angeles station that has data going back to 1877. The brown line is what you should expect in a normal year through late January, close to 7 inches. The green line that you can barely see is what's been received this year, and this was including some rainfall yesterday. And so the water year to date through yesterday was 0.27 inches, which is the third driest, going all the way back to 1877. There still, while showing this graphic, there were no soaking rains that have come so far for this water year. That has changed a little, and I'll show what's been going on with this current storm. But this table here on the top left is showing the consecutive days at this location with less than a tenth of an inch of precipitation. And that streak ran 264 days here, which was the second longest on record. And that ended yesterday, as this ran through January 24th. So just an extremely dry start, one of the driest that the area has seen. And so again, the dryness and the heat over the summer, just the normal heat of the summer plus above normal temperatures, has really led to drying out of the soil moistures along coastal California. This is a map of the 0 to 100 centimeter soil moisture in percentiles. So the reds are in the bottom of the barrel, 0 to second percentile, extremely dry soils all along the south coast of California, and even going a bit further north. Um, so we have extremely dry start to the water year, extremely dry soil moistures, and what that has led to is extremely dry vegetation and fuels. This map on the left, or this graphic on the left, I believe was from CAL FIRE. I'm sorry, I don't have a link in there, but this is showing the live fuel moisture content for the Southern California area. And it's hard to see, but there's a data point there from January 6th showing about 60% live fuel moisture, which is near that critical state. And it's actually more similar to what you would see in August or September. And so just extremely dry fuels. The map on the top right is showing the modeled dead fuel moisture for smaller branches. And basically this blue line was from this year, showing that it was close to that red line or below that red line, which is the lowest on record. And then what really, of course, drove the spread of the fire was the extreme wind event. This map on the bottom right is showing the maximum wind gusts from January 7th around the LA area. And we see some wind gusts in the 70s and even a few above 80 miles per hour. And so it was a high magnitude wind event, but it was also a prolonged event lasting almost 24 hours and maybe longer in some cases. So lastly, I just want to touch a little bit on this ongoing storm that actually has brought some decent rainfall to Southern California, which is really great to see. This table on the top left is from the downtown Los Angeles station for January. And so if you look, they had nothing all January, but yesterday there was 0.11 inches, which is great. And there's been more since then. The map on the right, I just grabbed this morning, which was showing the 72-hour precipitation totals ending this morning. And around the LA area, there's quite a few areas that have exceeded an inch in the 2-day totals. A lot of the 1-day totals are quarter inch to 3/4 of an inch. And so this isn't really the big storm that was needed to kind of bust the drought, but this is going to be really helpful in at least wetting the soils and the vegetation as a soaking rainfall, which is great. And this was driven by this cutoff low pressure system that is still meandering and still producing some rain and snow to the southern part of the region. And I will just mention a few key points here and then wrap up. So most of the drought that has been developing is short-term, driven by the lack of precipitation throughout the water year so far. There are still long-term drought impacts in southern Nevada, particularly related to Colorado River Basin water supply deficits. And there still can be a recovery in terms of drought precipitation and snowfall for this year. But something needs to shift soon since we missed all that January precipitation, and we're going to need some larger, most likely atmospheric river storms to deliver in February and March. And I will stop there and turn it back to Amanda.
Great, thanks, Dan. With that, I'm going to pass it over to Jiabao Wang from the Center for Western Weather and Water Extremes at Scripps at UC San Diego so that she can tell us if there is anything on the horizon and what that may be.
Okay, thank you, Amanda. Let me share my screen now. Okay, are you able to see my screen?
Yep, should be good to go.
Okay, great. Thank you, Amanda. Yeah, thank you for having me here to present on behalf of our subseasonal and seasonal team at the CW3E. Today, I'll be talking about the subseasonal experimental forecast products that have been developed by our center and by the external collaborators too, and touch a little bit on the latest subseasonal and seasonal SNS outlooks. This table is prepared by our team lead, Mike DeFlorio, summarizing the subseasonal research and experimental forecast products that from our center and also our collaborators. And I'm highlighting 4 of them. Those are the products that we include in our subseasonal outlooks. The first is weeks 2 to 4 AR activity outlooks that led by Mike DeFlorio and predicting the AR frequency. And the second is the weeks 1 to 6 region outlooks led by Peter Gibson is predicting the 3 dominant region types near the US West Coast. And the third is a statistical forecast product predicting the AR occurrence and the precipitation based on the conditions of band and Julia oscillation, MJO or dominant mode in the tropics, and quasi-band annual oscillation, QBO, the mode in the stratosphere, led by Chris Castellano. And the fourth one is the IRI weather regime outlooks that predict the 4 dominant weather regime patterns over the North Pacific and North America from Andy Robeson Group. And in addition, we also have 2 other forecast products. One is AR intensity, which has just become available on our public website, and the other is AR cluster outlook is currently in the research mode. So for the products I'm highlighting in red will be, I'll be showing their latest results, forecast results. Our center has been producing the SNS Outlook since 2020, and we usually issue the forecast from November to March. And to the right is our website of the SNS Outlooks archive. And here I wanted to highlight our core SNS Outlook team members, Chris Castellano, myself, Chichi, were taking the turns to lead every Outlooks. And we receive extensive feedback from Julie and Mike for every Outlook. And Marty is our director who initiated ideas of generating these Outlooks. Between the winters, we send our outlooks to stakeholders to receive their feedback. So here I'm highlighting Mike Anderson and Angelique from DWR that we receive their feedbacks to further refine our outlooks between the seasons. For the subseason outlooks, we provide AR frequency, North Pacific reach types, and the precipitation forecast. And for the seasonal outlook, we have mainly focused on the precipitation forecast. So for the subseason outlooks, they are being generated every week, usually posted out every Tuesday. And for the seasonal for this water year, we produced 2 seasonal outlooks. One is out in November, summarizing October to December outlooks, and the other is being generated this month, summarizing the January to March forecast results. Dan has actually covered pretty much of this. I just wanted to reiterate the current drought conditions over Southern California with severe to extreme drought and some droughts over some dry conditions over Central California. And also the precipitation, you see the water year to date with very below normal precipitation over Southern California and below normal snowpack over Central and Southern Sierra Nevada. And then I'll be jumping into the weeks 2 to 4 air activity outlooks. So here are the latest forecast results that initialized on January 23rd from 3 different dynamical models, NSEP to the left column and ECCC is the middle column, DCMWF to the right, and I have week 2 to the top and the week 3 in the middle and the week 4 at the bottom. I'm showing the AR activity anomalies, so where the greenish color indicating above normal air activity and the brownish color indicating the below normal AR activity. So if you look at the week 2 forecast from January 30th to February 5th, you tend to see that California and Nevada, for two of the models, NSEP and ECMWF, they're predicting the near normal air activity over those regions, while ECCC is predicting some above normal air activities over most of California and Nevada. And then when you go into week 3 forecast from February 6 to 12, the ECMWF still predicting mostly dry conditions over the Western US, while ECCC and NSEP models, they are suggesting the above normal air activity over much of California and Nevada, with still the persistent wet conditions for those two models. And the wet conditions for those two models actually persist out to week 4, that you see pretty much pretty much California and Nevada is having above normal activity for those two regions, while ECMWF is also start to predict some a slightly above normal air activity over southern California and Nevada for the week of February 13th to 19th. So at least from these two of the three models, you tend to see some above normal AR activity being predicted over California and most of Nevada around week 3 and week 4. And here I'm showing the weeks 3 and 4 region outlooks from N7 ECMWF models. So these forecast products are based on the study by Gibson et al. 2020 that they found three dominant region patterns that impacting the US West Coast. One is with the center to the north of California. They called it the north ridge types. And the wet ridge type is the center being to the west of California, and the south ridge is the center over the southwestern US. And here I'm showing their AR IVT and the precipitation from the paper. You see the corresponding precipitation types of those three region types. Um, and here, let's look at the forecast initialized on January 23rd for the week 3 and the 4 forecast from N7 ECMWF models. So here is the prediction of those three ridge types. And the blue dashed lines are the climatology, and the red dots are the ensemble mean. If you see the pattern of the precipitation that's very clear, that means the ensemble gradient is greater than 50%. So NSEP model is suggesting that for the week 3 and the week 4 lead time, that a south ridge type and a west ridge type, they both have a around moderate likelihood of occurrence, with 69% for the south ridge type and a 75% of ensemble gradient for the west ridge types. And they both suggest the wet north and dry south conditions over the western US. But for the ECMWF, that their forecast is generally more uncertain, that all the three ridge types have near normal predictions, with the dot being very close to the climatologies, and the ensemble agreement is below 50%. And the last subseason outlook I wanted to cover today is from IRI. They're trying to predict the 4 dominant weather regimes based on the cluster analysis on the 500 millibar geopotential height anomalies. So the figures to the right, to the left here, I'm showing the 4 weather regime patterns that they are trying to predict. And then to the right is the historical composites associated with each regime for the precipitation to the top and the temperature to the bottom. This figure is the latest, the forecast initialized on 23rd. I have checked the latest forecast with not too much differences with this one. And for this product, is predicting the daily, making the daily forecast out to 45 daily time, where it's shown as the y-axis. From the bottom to the top, you go from 0 to 45 daily times, and the x-axis is the initialization date. So, for example, I put the black dot here is the as of January 23rd, that the dominant region pattern is the West Coast region. But we know that California is currently being impacted by the low pressure system. So then also showed that the low pressure system actually pushed the region a little bit far to the north. And then we break the forecast into week 2, week 3, and week 4 forecast, where I make the mark here. So if you look at the week 1 and week 2 forecast, you tend to see that there is the red colors. The different colors of the forecast are representing the different weather regimes, and the darker the color, meaning the higher confidence of that regime pattern with the greater ensemble agreement. So for the week 2, we see the low to moderate likelihood of the West Coast ridge persisting for 2 weeks from week 1 to week 2. And at the bottom, I'm showing is corresponding precipitation patterns of the composite again to as a reference. You see that for the West Coast ridge is mostly favoring the dry conditions over the Western US, especially the US West Coast. And then if you go into week 3 and 4, there's a change of the color from red to blue, suggesting a possible regime shift from the West Coast ridge to Pacific ridge around week 3. But here's the moderate likelihood with about 50 to 75% of our ensemble agreement suggesting this regime shift. And then the Pacific ridge is also predicted to persist out to week 4. And then to the right, I'm showing the pattern of the precipitation based on the historical composites. You can see that if there is a regime shift, then the Pacific Northwest and most of the Western U.S. will be having above normal precipitation conditions rather than the dry conditions, while over California is from dry to near normal precipitation conditions. So our center actually developed what is called a subseasonal synthesis table. Is what we try to synthesize information of those forecasts because they are from different forecast products and also different dynamic models. And here we're focusing on 4 regions, subregions of the US West Coast, and making the forecast to week 2, 3, and 4 in the tables. We have the different models to represent NSEP ECC and ECMWF results, and we also show the multi-model forecast mean. We have 4 different categories. Below normal is in brown, and then near normal is in gray. Above normal is in green, and we also have the uncertain or lack of skill that we make it in white. So what you see here is that for week 2 forecast that the models they lean toward below normal precipitation over Southern California with a lower confidence with the pattern shading. And then precipitation conditions are more uncertain in the north and in central California for week 2. Also for week 3 and week 4 that the conditions are very are uncertain for California. But here over the Pacific Northwest, you tend to see some above normal precipitation suggested by the models. And this is consistent with a possible regime shift around week 3. And lastly, I wanted to touch a little bit on the seasonal synthesis outlook that we issued January that summarized the January to March conditions for this water year. So for this table, we include 2 products from our center, machine learning and the CCA seasonal precipitation forecast. We also include 4 products from other external institutions. And we make different categories of either plus sign above normal, below sign below normal, and then N is normal and U is uncertain or equal chances for North and Central California, Southern California, as well as the Upper Colorado River Basin, and where you see that most of the latest seasonal forecast results, they are suggesting that the dry conditions will persist over Southern California in the following 3 months, but for the other regions that the conditions are generally more uncertain. So I guess I'll leave my summary slides here because I may have run out of time, but I put my contact info of myself and my our team lead there. So if you have any questions, please feel free to reach out to us. And I also have put our website and Outlook website here. Yeah, if you have more interest to know that, please go to our website to check the latest outlooks. That I'll also put the links into the chat too. Thank you.
Great. With that, I'm going to go ahead and keep us moving towards our state climatologist perspectives. So we traditionally do this around this time of year because it's great to hear what they're hearing on the ground and what their perspectives are on the conditions and where they're going after we've heard the 2 great presentations, for example, from Dan and Jabao. So with that, Baker, I've passed it over to you. For folks that don't know Baker yet, he is the new, as of a few months ago, Nevada State climatologist at UNR.
Thank you, Amanda, and thank you for that. Those two excellent presentations. I just want to touch on a few of the points and provide perhaps a bit more current information as of today. And first of all, water year to date precipitation, I think, has been covered very well, but it's extremely below. We're well below normal, as we can see. This is from the California and Nevada Water Forecast Center, both from the water year, with the exception of course, Northern California that you see, and some areas in the Ruby Mountains and northeastern Nevada are showing, closer to normal values. And then month to date is extremely dry, so I don't need to rehash that. I also want to just highlight the observed mean temperatures from this is the Southeast Regional Climate Center's Climate Perspectives page, showing that we're in the top three in the Las Vegas, Henderson area, and of course moving into California. It's been a very warm, very warm start to the water year, and also well above normal in Reno and in Elko, Winnemucca, and other portions where we have longer term climate reporting stations across Nevada. A quick look at the composite drought indicators. So on the left, we have sorry about that. On the left, we have the short term CDI composite, which is a mix of various indicators. And you can see short term, this matches up very well with what we see on the US Drought Monitor, with very severe to extreme, in some cases exceptional drought showing up in the composite drought indicators for southern Nevada, and also just east of Reno here in west central Nevada. But then there's a sharp gradient as we move to the north on the short term composite drought indicators. Longer term, we're still doing fairly well across the state of Nevada. I mean, there's some pockets showing up, but again, with the reservoir storage that Dan showed earlier, that we're generally doing much better with the longer term composite drought indicators. A quick look at the SNOTEL snow water equivalent percent of median across these basins, and we see that much of the state of Nevada, at least, is in that. The basins, at least, are close to median, with the exception of the far west that depend on the eastern Sierra, and then the south, extreme south, the Spring Mountains, and into the Wheeler Peak area, Great Basin. They are in not very good shape at all. And so, pulling all of the SNOTEL stations from Nevada, as of this morning, you can see we have flatlined for the past month, and we're well below the median, and but we're still within that green range. We're at 78% of median for the state as a whole, and there is room to be a bit more optimistic with the pattern perhaps changing. If we look more closely at the Humboldt River, I think Dan had showed this plot as well. We're right at the pretty much right at the median at 104% of the median for this state. And so those early gains were extremely helpful. And then if we go to the Spring Mountains here in extreme southern Nevada, you can see there's hardly any snow on the ground at all. And this is hopefully changing with the storm system that's just looked as of this morning. At least there's an inch of snow on the ground now at the Lee Canyon site, with 0.2 of an inch of squeeze. So maybe this will start to pick up, but it's been a very poor start there. And then the 8 to 14 day outlooks from yesterday indicate a higher chances of below normal temperatures during that February 3rd to 9th period, and also perhaps a more active storm track developing. And that's consistent with what we're starting to see in the ensemble guidance. This is from the Utah Snow Ensemble precipitation and snowfall guidance for the Central Sierra Snow Lab. Beginning about February 1st, we're starting to see a much more active Pacific storm track, and possibly anywhere between 2 to 4 inches of SWE added in the snowpack at the higher elevations of the northern Sierra, at least. You can see upwards of 20 inches, perhaps with a lot of variability with the different members. And then looking a little bit farther out to the 11th, this is from the ensemble guidance from the European model. We can see nothing really through the end of this week, and then a much more active pattern developing. This is for Reno, 51 different simulations from the European ensemble. And so, the ensemble mean takes us up to about an inch of liquid equivalent there in Reno. And if I look at the South Lake Tahoe airport, we can see, again, a very active pattern starting to develop with a storm system over the weekend, perhaps another one the middle of next week, and then greater storm likelihoods as we look farther out. And this could result in, anywhere between 20 to 40 additional inches of snowfall. This is at the Lake Tahoe level. So this is an encouraging start to February. And what about after February 11th? Well, according to the ECMWF weeklies, which I just pulled, the week of the 11th through the 17th of February still looks to have a positive precipitation anomaly, so wetter than normal pattern, favored for at least the northern part of California into northern Nevada. And this general pattern looks to persist, according to the European outlook, at least from the 18th through the 24th. With, again, the main storm track, it appears, targeted to the Pacific Northwest. So I think my time is up. I'll start there and thank everybody. If you have additional questions, feel free to follow up.
Thanks, Speaker. We've gotten a few questions we've answered for in the background effects. If anyone does have questions on any of the presentations today, I forgot to remind you there is a questions box. Feel free to pop them in there. And we'll move on to our last speaker here with Mike, who is the California State Climatologist at California DWR. All right, Mike, we can see your slides, but I think you might be muted.
How's that?
You're good now, and I can hear you. Your slides looks fine when they're in presenter mode, but we need both, so we hear you.
All right. Do you see it now?
Yes.
All right, cool.
You're good to go.
All righty. So just want to take a quick look at our climate normals. Got two of them on there for you. The blue ones with circles and the triangle are back at the dawn of the 20th century. And you notice the circles are pretty close to the triangle being that climate normal, representing the average of those 30 years. You see a few extremes, including 1917 as a really cold year, 24 as a dry year, but a lot of them really close together. Now fast forward to our current climate normal, 1991 to 2020, represented by the orange squares as individual years and the diamond there as the average value. We see the squares are a lot further away from the diamond, so average really a waypoint between extremes, and we see really broad-based extremes: cold, warm, wet, dry included. So if you look at the table at the top, you find temperature is warmed 2 degrees Fahrenheit, but our average precip's only dropped to 10. So really about the same, but the variability definitely different. And we've seen that a lot of late. So what are we looking at this year? I want to highlight the California Water Watch. A great place you can go to look at all the different water metrics of California. We got our precip, snowpack, reservoir, groundwater, temperature, stream flow, soil moisture, and vegetation data up on the web page. We're also updating it to include conditions in the delta. So I have the graphic for the precip map as of January 25th, and it shows that statewide we have an average of 10.02 inches, definitely distributed much more in the north, Bay Area I-80 corridor, wetter than average. Everything south of there drier than average, and everything south of kind of Santa Barbara over to Bakersfield. Really looking at that 0 to 20% of average, just phenomenally dry. As a state, though, we're 86%. So in spite of the fantastic rains in November, which in some places north of the Bay Area were 44% of their water year in that 4-day stretch, we are definitely lagging. So building a water year, kind of showing the events that we've had. So, at the long duration AR in November, we had several weaker ARs in December, but we had some fantastic waves, including a record wave for surfing at Mavericks, a wave that actually destroyed the Fisherman's Pier in Santa Cruz, and some really strong waves, including some record setters up in Oregon and Washington. Get into January, we had the Santa Ana events, also the fires, and really, really dry times. On the bottom, you see what we're kind of expecting out of a water year. Our fall rains starting in October and November. For some places in Southern California, this storm represented those first rains. So you get to see just kind of how anomalous things have been. Our peak AR activity is at the end of December, beginning of January. Really didn't see that this year. 50% of our annual precip usually falls in December, January, and February. January is going to be a big 0, so it's going to be hard to catch that, and that usually makes it hard to hit average. Usually we see snowpack develop from December through March, with April 1 being the average date where we hit our peak snowpack. We will be having our February snow survey here coming up soon, and that will begin then our official Bulletin 120, which is our water supply forecast of the April through July runoff. Peak melt happening in April and May. April for the Northern Sierra, much lower elevation mountains than the Central and Southern Sierra, which peak later. Our water demand peaks in that summer dry season. Heat events are not an if, it's when, how strong, and how long, and where. As we get into the fall, we're starting to seeing more opportunities for those decaying tropical systems to potentially impact the state. We get to the end of September, we really look at that end of year target to kind of understand how we get ready for the next water year. So Climate Tracker at Western Region Climate Center, opportunity to look at some graphics from them. So this is the South Coast Drainage. This is Climate Division 6. 12-month summaries wanted to show the extreme heat in July, October, and December. So really a punctuated series of extremes, setting the stage for what transpired in January. Look at then the past 12 months of precip in the same region, and we see that big storms in February, right around the Grammys. Almost a whole year's rain in a week there, and then after that, things really falling off. But you look really from May on through really, really dry conditions. In fact, taking that July through December, we have had the 4th warmest. With, you see the other ones exceeding it being there in after 2010. So a lot of heat of late. Then we go for that July through December. We're the 5th driest, but we have less than an inch. Average this time would be over 5 inches. So a huge deficit. But you all can also understand from Dan's comment, getting an inch of rain in the region really does make a difference. Here's a map of the observed precipitation from the California Nevada River Forecast Center on the left, really showing where the precip has fallen over the last 24 hours. You see the little yellow spot there, north end of Los Angeles County. That was where we saw some debris flows on I-5 from the Hughes fire. Looking ahead, we see the atmospheric river, everybody's been talking about taking shape there with the higher precip amounts, again, north of I-80. The precip in Southern California is with the exit of the cutoff low the rest of today and early tomorrow. 30-day forecast, kind of similar to what was shown there with the 2-week outlooks. Wetter up north, drier down south. This is still a canonical La Nina kind of outlook. Go to the 3-month, similarly, but we really look and see that they are more certain of a dry outcome for the Southern California basins, which will mean then some pretty dry conditions. But let's talk about the rest of the water year. So building a water year in the fall, like I said, look for that precip onset. What are the temperature anomalies and what's the soil moisture state with snowpack initiation? If it's dry before the snows set in, 100% snowpack does not equal 100% runoff. Now, we had a lot of rain with the storms in November and December up high, so that's not an issue. It's just getting enough snow to have a snowpack and runoff. The big three, December, January, and February, really looking at those wet and dry anomalies, with this January anomaly being one of the bigger ones. We often have a dry spell as we head into the new calendar year. Sometimes it lasts a few days, sometimes a week. This one's over 3 weeks and really quite impactful. Spring, really looking and seeing, do we get kind of a strong finish to the year or an early shutoff? Looks like we may at least get closer to average, which will help. That will impact when we hit peak snowpack, how big it is, and then when, and then that affects then the runoff that we have. As we then look ahead to the next summer and the dry season, how fast do things dry out? What are the heat events? Any tropical activity, which can be anything from torrential downpours to just lightning outbreaks, which can lead to more extreme fire conditions. And then everybody wants to know, given that we're looking at a dry year this year, we'll get around April 1 with that peak snowpack, they'll want to know, well, what about next year? Not something we're really strong at, but we do have some folks and colleagues at NOAA working on that, which is kind of exciting. And then understanding that this decade's going to be different than the last one, and as we update that normal there in 2030, this decade's going to look a lot different than 91 to 2000. So keep that in mind, because that becomes the background that your average is set on. Now I'll just finish up here with some of the warmest and driest for Climate Division 6. And this is monthly data. So we look at the wet season, October through March. Worst year in terms of dryness was 2007. And you also look at the top 5 and notice that 4 of the top 5 are in the 21st century here. Looks like we will be kicking 1961 to the curb unless things turn around pretty significantly. Warmest, right now we are definitely cruising in for Climate Division 6, depending on how the rest of this winter goes. And with that, I will end the presentation and hand it back to Amanda.
Thanks, Mike. Well, thanks both Baker and Mike for your great perspectives for the 2 different states in our in the drought early warning system. Mike, before I pop up my closing slides, there was a question for you in here about the time periods used for your first slide of evolving normal 30-year averages. The comment is they're not aligned with, for example, PDO cycles, which are typically 12 to 30-year duration. Why not use these?
Right. So what I used were the NOAA-based climate normals, which are updated once a decade. You are right. There is decadal variability that is outside those bounds in the PDO cycles. We don't have a lot of them. So really kind of a trick to say anything about whether we're in a pluvial wetter streak or in the drought drier streak. There is some speculation that with the triple La Nina we had beginning of the 2020s here, that was a possible transition into a wetter cycle. We will have to see. We're much better at diagnosing those things than we are in actually using them in a predictive capacity.
Great. Thanks, Mike. With that, we're basically at time. If you do have any further questions, feel free to email me directly or the speakers so we can get those questions to folks as they need them. And thank you again to both Dan, Jibao, Mike, and Baker for your great presentations. As I mentioned to everyone, this has been recorded and will go up on YouTube probably later this afternoon. With that, our next webinar is March 24th. You'll probably hear from us also with the drought status update in between then with more upgoing information. We're going to try to pump out as much information as we can as conditions evolve through the spring. If you want to sign up for our newsletters, you can go to the QR code there. That way you get things sent directly to your email, or you can just go to our site or go to all the different great other websites like California Water Watcher or things like that. And with that, I'll go ahead and wrap up and say thank you everyone for joining us, and I hope you have a great week.